So in this video, we're going to talk about factoring quadratics with a lead coefficient of 1. You can see all of them have 1 in front of them. They also have a middle term. So factoring when there is no middle term can be a little different, especially if you're just missing a 16. So for instance, if the 16 was not here, then you would just be factoring by GCF factoring. So what do you do when you have all three in a quadratic and you have to break it into its parentheses that you multiply together in a previous chapter? Well, it really boils down to understanding that when you take this problem apart, so going from left to right, you're going to go from right to left. So you're going to start with C and you're going to go this direction, and your object is to get B, this being A in the front. That's what I meant by A is equal to 1. So it really boils down to multiplication tables of C. So C is 1 times 16, or it's 2 times 8, or it's 4 times 4 from elementary school. And so once you have figured that out, those things from elementary school, you need to look at this portion, which tells you to add these factors from elementary school to get B. There's only one clear choice. 2 and 8 add up to 10. So if we're going to get x plus 2, and then x plus 8, and you're literally done. That's the end of it. I could have used x minus 2 and minus 8, but that would have given me minus 10. But it would have given me 16. Keep that in mind when we look at number 3. So some students will say, that was so easy. How did that work? Well, if you use a multiplication square or the square of the box method or the area model, whichever you learned it as, and you come over here and you were to put x plus 2, and then here you put x plus 8, and you multiplied it out, you'll see how it works. This is x squared. This is 8x. X times 2 is 2x. And then 2 times 8 is 16. And then when you add your middle terms together, you get the 10x. And you can see that I have the 16 and the x squared from the original problem. All right, so what happens if I need to break one apart with subtraction? Well, nothing really changes. I write down my parentheses. I'm going this direction. I use C to find B. A in this case is 1. We'll deal with A not being 1 in a separate video. So the multiplication tables of 12 are 1 times 12 and 2 times 6 and 3 times 4. But now, big surprise, we need to subtract now to get negative 1x. So we know it's 3 and 4 because 3 and 4 will give me 1 when subtracting. So when you do this, you put the 3 and the 4 in. I always like to put my smaller factor first. That's important for later when we take our tests because I always put the smaller integer first. And then you use subtraction, which is made up of a plus and a minus to get negative 1. Now you've got to be careful. You're going to put the addition sign here and the subtraction sign here so that you get negative 1. And again, if you want to see how that works, it always helps to use a little bit of our prior knowledge from using one of these multiplication squares or box method to do this. So what happens is here we have x plus 3, and then here we have x minus 4, and you'll see that we'll get x squared minus 4x plus 3x, and then minus 12. Notice that we have our x squared and our minus 12 from the problem. And when we combine this, we get negative 1x. Had I had the negative on the wrong thing, I would have gotten positive 1x. All right, so let's look at this one. Again, same game. We're going this way. We need C to become B. So we need factors of C to add up to B. So 1 times 6 and 2 times 3. This is the one that adds up to 5. Notice how important this portion is, because isn't 1 minus 6 negative 5? But I can't use subtraction. The problem is demanding addition. So what I'm going to do is I'm going to put 2 and 3 here because I know I'm going to get 5. And then I just have to think, okay, well, in pre-algebra, what two things can make an addition sign? I can either multiply 2 additions, or I can multiply 2 subtractions because 2 negatives make a positive, but when I add them, I get negative 5. You can multiply that back through if you want to see it. All right, so let's do a couple more. 32, I have 1 times 32, and I have 2 times 16, and I have no 3s, but I do have a 4 times 8, and again, this one is demanding that I use subtraction, so it's going to be 4 and 8. Just make sure when you do the subtraction ones that you actually get positive 4 or whatever they're asking. So I know it's 4 and 8, but I need to make the positive go here and the negative go there so that when I add those up, it's positive 4. So 24, again, once you know the secret, factoring becomes so much easier. 2 times 12, there is a 3 times 8, and there's a 4 times 6. So none of this matters. I know there's a lot of it. I just need the one that will subtract to 2. That's 4 and 6. So once you know what they're asking, they're saying take 24, write out the factors from elementary school. In fact, these are actually called factors in elementary school if your teacher used that language. And then find the ones that'll subtract the -2. Well, that's going to be 4 and 6. I always put the smaller integer first. And then we want it to be negative, so that'll be minus and that'll be positive. 6 minus 4, sorry, 4 minus 6 is -2. And the x comes again through multiplying it through. So here's another problem with 6s and 5s. They tend to be the hardest ones, but they're actually easy if you do it correctly, because we start with C. The only factor of 5 is 1 times 5. We go this way. It demands that we add up to 6. So we're going to get x1 and x5 to get 6. And then they both need to be negative because 2 negatives make a positive 5. But when I add them together, I get -6. So the one thing that people will ask me is, well, what happens, Mr. King, if they, kind of throw me a curveball? So here's a normal curveball that you're shown on, I don't know, PSAT and SOL, is they'll add like an extra Y in here, something like this, okay? And when they do this, notice that all I did was take a problem that we just saw and I kind of just like camouflaged it. Nothing changes when this happens. What you do is you do 1 times 5 again, right? So you just act like this Y isn't here. It wasn't there a second ago. And so you still have X and you have X and you have 1 and you have 5, and we're going to use 2 minus signs to get 6. And all you do is then, once you've ignored the Y, you just put that Y back in there. You're like, okay, well, there has to be a Y here and there has to be a Y here because Y times Y is Y squared. And again, if you really want to see what's going on there, I think the best thing to do is to use, this multiplication that you learned earlier. It'll show you how it works. I mean, once you believe that it works, it's pretty easy to just agree with it, but let's make sure we agree that it works. So what happens here is here I get x squared. X times y would alphabetize to xy. That's how you get that xy term. This would be minus 5xy, and this would be minus times a minus is positive 5, y times y is y squared. So you can see now that I have the x squared and the y squared, and then these middle terms here will add up to -6xy. The other thing that students have trouble with is what happens if the middle term, right? So let's say your middle term looks like this. Let's say you have something like x squared minus, I don't know, a perfect square like 16. And so some students will get very confused and they'll say to themselves, Mr. King, there's no middle term. What do I do? Well, there is a middle term. The middle term is 0. Okay, so when you think about it like that, the question now becomes, okay, what factors of 16, again, start in elementary school. So factors of 16 are 1 times 16, 2 times 8, and 4 times 4. Well, which of these will subtract to give me nothing? That'd be x plus 4, x minus 4. And that is known as the difference of squares. You might have memorized the difference of squares as a squared minus b squared is always equal to a plus b, a minus b. And what that's actually saying, right, is that you have the first thing repeated, right? The x is x and x, and then the b, they don't tell you this in the formula, it's actually the square root of that integer. So the square root of 16 is 4. And if you add and subtract them, you always get no middle term. All right, I hope that video was helpful, and I will make another one about lead coefficient of a greater than 1.